All right, guys. So today we're doing 3.5E solving rational equations. It's a three-part situation. So part one is going over adding and subtracting, because when you're solving, you may need to add and subtract, right? Part two is going to be going over what's called complex fractions. And so complex rationals. And so we'll be looking at those. And then part three is ultimately the solving. Okay. So we're going to go through this again as we're going through it. Ask questions, stop. I will probably leave some of the problems for you to practice, to try. It's just that due to time constraint, we will not be able to practice and try as much in class as we normally do. Okay. Because I want to make sure we get through the gist of it so that you have all the general information to do the problem. Okay. So starting off, we're going to start off with part one. Part one is adding and subtracting. So when you are adding and subtracting, just like any other fraction, they need to have a what? Common denominators, right? In order to add and subtract fractions, they have to have a common denominator, okay? At this point, guys, you don't need computers. You should be paying attention. You should be taking your notes. You don't need any devices, okay? So when we're doing this, the first thing we want to do is factor the denominator. The reason why we want to factor the denominator is to figure out what is our LCD. Remember, LCD is your least common denominator. So very similar to least common multiple, it's just your least common denominator. That's all it is. So what is the smallest number, number or variable that I can multiply both fractions by so that they can have one denominator, okay? So then we're going to multiply each term to get the denominator, LCD. And then remember, what you do to the bottom, you have to do to the top. Because the goal is that you're just creating a one in disguise, right? We're not trying to change the value of the problem. We're just trying to change how it looks. Does it make sense? You're not changing the value, just how it looks, okay? Then we're going to add and subtract to combine like terms. We're going to simplify more if possible, and you're going to simplify each sum or difference, and then state any restrictions on the variable. So state anything that would make our x's, our denominators at any point equal to 0, okay? All right, so we're going to start here with the first one. So example number one is where our denominators are already factored, right? There's nothing else I can do. They're both fully factored, okay? Step one says we're going to factor the denominators. Check, step one's done. Step two says to find your LCD. So for this problem, our LCD is just going to be both factors of the denominator because they have nothing in common. So it's just going to be x minus 1 times 2x plus 1. Okay, so that's what step two is telling you, to find your LCD. Step three, it says to multiply each term to get the denominator. So when you're looking at the first fraction, you're asking, well, I already have x minus 1, but I don't have 2x plus 1. Does that make sense? So I'm going to be multiplying the first fraction times 2x plus 1 over 2x plus 1. Okay? I'm going to write it bigger and better in a second, but that's what it's saying. Then you're asking yourself, what is the second fraction missing in order for it to have a common denominator? X minus 1. So I'm going to multiply the top and bottom by x minus 1 times x minus 1. Okay? What this allows for you to do is to be able to combine the fractions by giving them one common denominator. So now our common denominator is x minus 1 and 2x plus 1. In our numerator, we have 2x plus 1 times x plus 2 plus this side, we have x minus 3 times x minus 1. And now instead of two fractions, we have one. So at this point, you're going to multiply and combine like terms, right? So we're going to just FOIL our little selves away. So when I FOIL, 2x times x is going to give me 2x squared. Then I have 2x times 2 gives me 4x. Then we have 1 times x gives me. And then we have 1 times 2 gives us 2. Okay, we're gonna do the same thing on the other side. X times X gives us. X times -1 gives us. -3 times X gives us. And then -3 times -1 gives us a +3.
No, just one.
So we'll combine, and we're gonna now multiply the denominator. So we have X times 2X is. We have X times 1 is. -1 times 2X is. And then -1 times 1 is -1. So we've now completed step 3. We've multiplied everything out. Step 4 says we're going to do what? Now it's time to combine like terms. Add and combine like terms, right? So now we're on step 4 of adding and combining like terms. So I have 2x squared and 1x squared. What is that going to make? 3x squared. I have 4x, 1x, -1x, and -3x. 4 plus 1 is 5. 5 minus 1 is 4. 4 minus 3 is 1. So it becomes plus 1x. And then last are my constants. So we have 2 and 3, which makes 5. Now we're going to do the denominator. The denominator, 2x squared, has no friend. But we have 1x and -2x. What does that make? -x and then -1. So your sum is this. Okay. Now it says to simplify more if possible. When it says to simplify more if possible, that means I'm going to check to make sure that nothing can be factored and eliminated. Okay. So when it's telling me to simplify more if possible, I'm just going to do a quick factor check. If I did 3 times 5, my A times my C, that's 15, right? Is there anything that's going to multiply to give me 15 but add to give me 1? No. So can I factor that? No, it's not going to come out to be a factor of a small or reasonable number that's going to eliminate. Does that make sense? Okay. So simplify each sum or difference. I've already simplified. I can't go any further. Simplifying's done. The last part is to state any restrictions on your variables. Okay. Your restrictions for your domain go back to your original for the most part. So you're going to check the denominators, your LCD, which was your least common denominator, right? So when I'm looking at my restrictions for adding and subtracting, I'm going to look at the LCD. So looking at my LCD, what are the restrictions that X cannot be? X can equal 1, and X cannot equal negative what? -1/2, because I would have to subtract the 1 and then do what? Divide the 2, because the goal is to get X by its self. So again, these are coming from the fact that I would have X minus 1 equals 0 and 2X plus 1 equals 0. And what do I have to do to get X by its self?
Oh, I get it now. You have to divide it.
Yes.
Because it's the denominator?
Because it's your denominator. And our denominator can't equal what? 0. So when you're adding and subtracting, you're trying to find your domain restrictions, you're going to look at your LCD. Okay. So the first example we had was that they didn't have any common factors. The next example we're going to look at is that, they're going to have a common factor. So example number 2, we have X divided by X squared minus X plus 1 over X. Step 1 says to make sure that your denominators are factored. So this one's good to go, right? I'm not going to touch it, but is this fully factored? No, this can be factored by using your greatest common factor. And the GCF here is X. So when I factor out X, I'm left with X times X minus 1, right? Do we all see that? So now I can state the LCD. So your LCD is first, what do they already have in common? X. And then what do they not have in common? x minus 1. So this is your least common denominator. So looking at the first fraction, it already has our LCD, right? But looking at the second fraction, does it look like our LCD? No. What is it missing? X minus 1. So I'm going to have to multiply the top and the bottom by x minus 1. And again, this is just 1 in disguise, right? Anything divided by itself is 1. So now I can write it as one fraction. So we have x plus 1 times x minus 1 all over our least common denominator, which is x times x minus 1. The goal of an LCD is to get from 2 fractions to 1, okay? To get from 2 to 1. So now we can go through and multiply. So we multiply. Now we're going to distribute and keep it pushing. So we end up with x, distribute the 1, which just makes it plus x minus 1 all over x squared minus x. Combine like terms. Our like terms are x and x, which makes 2x. It becomes x squared when you multiply, but when you're adding, it becomes 2x. All over x squared minus x. There's nothing I can simplify. There's nothing they have in common. So this is my sum. Okay. I go back to my LCD to find my restriction, right? So step 7 is to find your restrictions. What are the restrictions on my x's? X cannot equal 1, and what else? 0, and x cannot equal 0.
Oh, yeah, that makes sense.
Because if I plug in 0, it's going to make everything 0, right? If I plug in 1, then it makes this 0. X cannot equal 0. X is a single factor here. It's a monomial. So that means if x was to equal 0, it would make everything else around it 0. It annihilates everything else.
So that wouldn't be 1 with it.
Okay. Our last example is when one fraction does not have a denominator. Well, what do? You put it over 1. When you don't have a denominator, it's Casper the Friendly One pops out. And now does it have a denominator? Yes, it does. Okay. When that happens, your LCD is just going to be the only denominator that's present. And the only denominator that's present is y squared plus 3y. Okay, so this fraction is missing y squared plus 3y, which means that I'm going to have to multiply the numerator times y squared plus 3y. Does that make sense? So we end up with 4y times y squared plus 3y. This one, I don't need to touch, right? The LCD is the denominator, so it's just going to be minus y plus 2. Notice that when a minus follows, I put a parenthesis, okay? The reason why you have to put that parenthesis is because when you're subtracting polynomials, the subtraction applies to every term, right? Not just the first term, but every single term. So when you're subtracting polynomials, make sure, and our denominator is y squared plus 3y. So now we're just going to distribute and combine. 4y times y squared is y cubed to the third power, right? 4y times 3y is going to give us 12y squared. Now we're going to distribute. Negative times positive is a negative y. And a negative times positive is going to make it a negative 2. And this is all over y squared plus 3y. Factoring this will not help. It will not eliminate. It will not get rid of anything. So guess what? This is your difference.
How do we know when factoring is done?
So you can, if you look at your factoring techniques and start factoring out mentally, is probably the best way to think about it. So mentally, I look at this, I'm like, oh, this would be a grouping, right? I would group you and I would group you and I would group you, right? When I start grouping though, this is gonna factor out to become 4y, y plus 3. When I group this one, it's gonna factor out to be y plus 2. Can I do anything further past that? No, because your binomials have to be the same. And my binomials would not be the same, so therefore, the factoring is not factorable.
Can x ever equal 0?
Yes,
So if you have a negative x and the x happens to be 0.
it's still 0.
Negative 0?
I mean, it's just 0, it cancels it out.
You're not going back to negative 0.
Yeah.
I just thought, like, it can actually happen. If you have
0 is
negative
neutral, so it can't be positive nor negative.
x, but what if it's negative x? If the x is 0.
Well, your x cannot equal 0 if it's in the denominator, so 0 is gonna cancel out anything. Yeah. It's kind of like a bomb in a fraction. Okay,
Thought I was on this one.
all right, so when I look at this, it's not gonna get me any further, so then there's no need to factor. All right, last but not least is to state your restriction. To state your restriction, you go back to your LCD, right? Right now, my LCD is not factored because we didn't do step 1 and fully factor. But if I was to factor this, I would take out y, and I'm left with y plus 3. So what are my restrictions on my domain? Y cannot equal negative 3 and y cannot equal 0.
Oh, yeah, because
It's a y factor by itself. If I plugged in negative 3, boom, it'll blow up my denominator. If I plug in 0, boom, it'll blow up my denominator. Okay? All right, so that's part 1. I wish we could.